Okay, so uh, good evening, everyone. My name is Ishan Rao, and this is the 11th session for programming in Java. Uh, Today, we will going to continue with what we have done in the last session, and that is this Tuesday. That is Java collection. Uh, so we'll continue with that, and we will look into hashing trees and map, say sets and map into this session. Okay, so we'll start with that. Uh, so let me start by sharing my screen. Okay, I think my screen has came up. Uh, yeah, awesome. So till now, like now you have covered a lot of things in Java, starting from classes, inheritance, encapsulation, uh, or uh, abstraction, interfaces. Lot of things are already we have covered. Now, Java has provided us some basic uh, tools or data kind of data structures which we can, instead of creating on our own, we can use them, right? For that, the Java collection as a framework was there. So last time we have covered basic of some of the basic functionalities of collections, but now we will go specifically with respect to uh, the kind of data structures that Java support through this collection, which you can use it while building your own application for storing the objects. Okay, so the first thing that we're going to look today is basically hashing. That is the concept of hashing, which will lead to see in the concept of hash set and hash map. Okay, now set are you basically the kind of data structure which are unique, so no duplicate elements. We will see their implementation as well. Okay, so but as a set, it always have a cost uh, associated with it, because while adding an element, we have to see each and every element that whether it's present or not, right? Now if the set became very large, it's a very costly operation, that is linear operation, to just to add an element, right? So to reduce such kind of mechanism, a mechanism called hashing came into picture. So hashing, what it will try to do is it will uh, try to assign a kind of identity or a number or integer to that particular element. So how it will do that? So let's say we have a whole set of elements. Now it will try to divide that elements into two buckets. Let's say we have created two buckets. So it will, based on a certain mechanism, it will try to each element either in one bucket or another bucket. So how it will happen is, so let's suppose we just first need to know that in which bucket the element exists. If we know that element exists in this, suppose bucket 1, so we will just search the elements of those. If we do in the bucket 2, we will search that. So what will happen is the lookup time for adding element will reduce by half, right? So if we have 4 buckets, the more bucket we have, the more lookup time will be less. And in such cases, so if you want to add more and more element within a set, and in a set case, you can reduce your timing to look at all the elements, and then you can add the element. Okay, so that's a conceptual aspect of it. Okay, uh, and and hash code has its own way of dealing with it, so we are not going exactly how hash code has been implemented and all that. But a hash code is any valid integer, okay, any of one of 2.4.2 billion number that is taken care by Java itself. Okay, uh, so let's look at it. Maybe okay, I think I will come here in this aspect, but let's look at from the code. So I've created a package, sorry, I have created a session 11, this session 1. In that I have certain packages which I want to cover this one. So one package is hashing. So in this I have a main function, main file as hash main. In this, public static void main is there. Now what I will try to do is, let me try to create few strings here. So let's say a text, p text. So I will create 5 strings of same hello, but in a slightly different ways. So I just want to do that. So let me do it a little fast. So I will create 5 hellos. One way is 2 is directly, so then is string dot join l elements and low. That is one way of writing this. Or e dot concat llo, and last is just hs small. So we have 5 strings that we have created, all leads to hello only. Now we will create a list of strings, basically array list, and I'm keeping the variable name as hellos. I can keep as instead of array list I can keep it directly as list only, that is fine. So I will just convert this things as arrays as list using array as list function, and I will add these variable names. So let me copy this. Okay, now the only thing I need to do is now I will create its hash code. So hash code is something is by default given by Java. So it's as function only. So we will print a hash code for each and every function. For each s less than system.out.println s plus, and for each hash is hash code. Okay, so basically it's a lambda expression that we're trying to do. For each come from the lambda expression. If you're not able to, just let me know. But last session I have explained it. So what we are having for every element from hellos, which you're taking as one as s, we are printing out that particular element. Then in this case one hello and its respective hash code. So if I just run this code, it's taking some time to build. Okay, so let's look at it. So it is giving me 4 values, for two hash codes, because all hash codes are here are same, that is 690, 9650 and all that, because all the hellos are same. Only for hello with small h it is giving me different hash code. So what does it means is, the when you're providing calling this s dot hash code, it is checking, it creates a bucket, and in that it check that whether an element first hello is there, so it will provide one hash code directly. But when I'm providing another hello with capital H, it is finding that whether it can be present in the same bucket or not. So it look at for the equality of between two elements. Since here the first 4 elements are same, hello as like that, even though we have created using different mechanism, the hash code will provide as same. Only difference where it's coming is small h, where the hello with small h, it is considered as different because it's not the hash code feel like it's not exactly equal. So based on that it's providing as a different bucket with different hash code. Okay, so likewise if we add more and more, so based on that, or we can also specify, as we see go along, we can also specify that how many buckets we have to create, or what are the comparison criterias in which we can compare an element. In this case by default the elements of hello are compared by their how equal they are. So 4 hellos are same, spell character wise as well. So it provides the same hash code bucket. Otherwise, the other last hello will provide us a different bucket. Okay. Uh, that being said, uh, let's try to bring here. So, so as I said in this, that elements are being, we have to, while using the hashing, we have to the elements are being compared with one another. So here also hashing start with the understand the equality of the objects. Okay, so it use two functions for it, that is use boolean equal and the hash code method. Okay, so okay, so what it will do is the current object, in this case that the list of this variable a dot text which is present in list, it will be gone, and it will compare with the equals object. Okay, this equal to object. Now once we do this, it means that it's trying to assign a variable to a reference variable name to the same memory. Okay, so it kind of act as an equality test. So they're saying that object can be considered equal in other instances as well if the attributes are equal. So in this case hellos are equal, capital H was the main thing, uh, only difference was capital H and small h. So these are the only two differences are there, uh, but otherwise all things are there. Other characters are same, but still it requires all the attributes has to be equal. But we can override these two classes according to our need, and we can write our own method of how object values attributes should be equal, right? Here only we have the string names, but if we have an object where we have multiple attributes, we can also define that how two objects should be compared enough, and once it compared enough, if it is equal, it will assign the same hash code, otherwise it will provide a different hash code. Okay, uh, so let me create the same thing now as a different way. So let me create a hash set out of it. So I will use a set as an interface of type string, my set as given as a variable name, and which is a hash set. Okay, and in this I will add the list of hellos. So I've created a new hash set. Okay, it is referred as set because uh, the hash set what to say inherit the set interface, that's why. So once we have this, I will just print it out this hash set as well. My set, and also look at the system size as well. So system.out.println number of elements, my set dot size. Okay, my bad. So if I just run this code now, also I can get the hashing the values out of it using get functions also. So let me write the code while it builds uh, for it also. So here we have added all this hello, 5 different hellos extracting from different ways into the as a list, and then followed by as a hash set. So now it's giving some output. Yeah. Now what is happening here is set can't contain duplicate. So earlier as a list it is fine, but when we are using hash set, we are getting only two values of two hellos, with one with capital H and one with small h, and the number of element is giving us 2. Okay, so that is one thing important need to remember, that set doesn't contain duplicates. Okay, now let me traverse through them one by one and try to get some value out of it. So I will write a for loop, simple for loop. Just a minute, just close this output. So for string set value, from the my set. So we are taking one element at a time. System dot out dot println set value plus and then I will go again for each this thing int I equal to 0, I less than hellos dot size, the array list of hellos that we have, I plus plus, we are traversing through them one by one, and if set values is equal to hellos dot get I, so I will find of this and then system dot out dot print I plus comma, and once I write this I'll just dot println. So we are comparing each one with set value, and then if I just run this code, we'll get the output and then we will see that what this code will look like. Okay, so we got certain values here. So if you can see here, something has happened. Now we have two my set. Okay, we have two things. One is my set, which is coming from hash set, that is one, and hellos, which is coming as a list that we have created. Now the hellos are coming from these 5 variables, and we have written hello in a 5 different ways, sorry, 4 different ways in this case. Now what we have done is, when what we are doing, we are taking one string value that is from the set my set, and we are traversing it with hellos, the list. From there we are extracting each and every element, in this case hello, and if the set value is equal to like that, it is printing it out the particular ith value. So what is saying that the output saying that the hello that is present in the my set with capital H, it equates to 0 and 1 type. It doesn't equate to any other hello which is coming from C text or D text. Okay, so that's the one thing. And the fourth one, the small hello, is coming from the small hello in this my set. It is equate to this hello of the E text. So why this is happening? So let me look and go through this type. Okay, so this is the kind of visual representation that we have. So this is hellos that we are having, the list that we are having here. So it has A text, B text, C text, D text, E text. Okay, now it is this hello that we are defined for in A text and B text, it is considering as a same reference variable. Okay, because it is as same values, it has same values, and it is not generated through any other means. Here C text and D text is coming from the join as well as contact function. So it has even the same hash value, but it's not contained in the same bucket. In the hash collection, even though these values are same, they haven't put in the same collection. So we have only one hello value, but we have two references variable, A text and B text. And while for hello, which is starting from H, it is different from the other 4 variable values, so it has bucket number 2. Okay, so basically it has to tell that A, B pointing to the same string instance, so that's why it is able to find the current my set the hello with capital H is equating to 0 and 1, while the hello is coming from to last element of 4. Okay, now so what is happening in the background? So it locates element to by match by first deriving the bucket. So it is deriving the bucket based on these two highlighted lines, this thing, and then compare those elements to the next element to be added or not. Now once you have this third and fourth value, even though same, they are not going to add because already present there. Okay, now let's do something else with respect to this. Is a basic concept of hash coding, right? Let's create a class and then we try to create see that how the hash code will play into the picture. Okay, so I have a class already made for this. So it is a public class called playing card. So playing card has three aspects, that is its suit, its face, its internal hash. Okay, some hashing related to it, some integer value. Suit is basically anything like club, diamond, spade, like that. Face is like queen, joker, queen, king, or ace, like that. Now we have its make its public constructor where we are taking only suit and its string faces, and it will create an internal hash for it. Okay, so let me just for now let me divide to 1 right now. Okay, and it has public string to string value where we're returning face and face of particular suit. Okay, now as we are creating using the hash code hash set, and it requires two functions, that is equals and hash code with respect to it. So each object will first go through the equals function and then followed by hash code. Now these are all automatically generated by the IntelliJ, so I have not created it, but for now I just want to show that how it works. uh, so first let me write the code in the main function and then talk about the equals and hash code function. So let's say playing card, ace of hearts, new playing card, heart, ace. Okay, then another playing card, king of clubs, new playing card, clubs and king, and last one more playing card, queen of spades, new playing card, spades and queen. Okay, so since we have the suit which contain it asking for suit and the face, so we are mentioning it explicitly. Now let's create a simple list out of it first. So list of which consists of playing card, and well, let's say its name is at cards. Now arrays at list, we will give this ace hearts, king club and queen spade, and we'll just print it out using for each method. And we just print its hash code. Okay, uh, I think for now let's do this, and let me run this code first. Okay, so we have created three playing card with three different name, ace of heart, king of clubs and queen spade, and we got some hash code value here, plus negative. That is fine, that is not something we are computing, so let it the number as it is. So this is something that we have to keep in mind. Now let's do it. Now instead of putting this card in list, let's put that in the hash set. Now as we can see, we have three different hashes here. Okay, now let's see that id, it should add it into the hash set as well with the help of different hashing, but let's see how it will go. So I will create set a variable called dec of hash set, and for playing card C from cards, so I will traverse each element in the list. If deck.add C is not present, sorry, if while adding the deck.c, if it is not equal, uh, it will add, otherwise it will print it out as found a duplicate for C, and then finally I will just print it out deck. Okay, so what I have done is created a hash set. In that hash set, I want to add each element of array list of cards one by one. So while I'm doing this, I will check that while adding the card whether it's present or not. If it is present, I will just print it out that found a duplicate for that. So if I just run this, okay, so everything is working pretty much fine, and it is giving me ace of heart, kings of queens, spade, because these are different one because of different uh, hashes that we are having, right? Now let's do something different here in the playing card code. Okay, now why it is working, it has different we got the different hashes because of this hash code function, and it is and always while adding before it it invokes the equal function as well. So what I will do is I will just comment it out for some time, and I have written the same thing as a overridden function for equals and hash code. Okay, now what we are doing here is hash code and equals are present as a string object, and so we can override them when we are using a hash set as well. So in this what we are doing is for each card whenever we are creating, so here we are creating 3 cards, right, for ace, hearts, king, clubs and spade. What we are trying to do here is we are giving internal hash as 1 by default. Okay, and when it is going to when the hash is going to add it, it will first check for the equals. Okay, and what we are doing whenever it is adding a card, it will just return true, that like that. And once we added and when once the object has been found as equal, we are calling for internal hash. It calls for hash code and we're just returning internal hash that we assign as 1. Okay, so for all the what you say uh, for all these values we will exactly get the same internal hash. So if I just run this code by, if I change the hash code function and equal function, if I do that, let's see how the output will work out. Okay, now earlier when we did that, we found that we have different hash code, but now we have defined all the hash code as one, as one only. Okay, that we have done it here in the internal dot hash, right, when the kite was creating. That's why we got this value 11111. Now when it's come time to add one element at a time, so what it is doing is first it might be looking for hearts of ace or kings of clubs in this case, say art of ace, so nothing was there, so it had added it already in the hash set. Now when it comes for kings of clubs to add, so it checks for the playing card equality, and because the hash code is same, it is saying that founding a duplicate for kings of club. Okay, now if I'm trying to again when it comes for queen of spade, since my hash code is same, it is not going to add it. So it's not only check it for hellos that we have seen earlier just now, that we just look, it just not only looking out for same element name, it also basically look out the hashes of that. Okay, that is what I want to convey with respect to hash set. Now let's do some more changes here. So instead of doing internal hash 1, we will do this dot internal hash, and whenever a suit is equal to hertz, um, if it is true, it is giving providing 111, otherwise it's providing 12 for others. Okay, as the internal hash. So if I just run this code again, um, okay, so what this code led to do. So what this code is doing is, if my ace of heart is if heart is as suit is there, so it is providing 11 for So for if the suit is anything different from heart, it's providing us 12 and 12. Now that means since I have two cards with the same internal hash, I can have only one uh, card present in my final hash set. So in this case, the kings of club, which has added already, that has been added along with the ace of heart. But when it comes for checking the duplicate, playing the card equality for queen of spade, it is saying that no, we have found a duplicate because our hashing code is same. Okay, so to summarize that how hash set is working right now is, so if you want to add an element in a hash set, okay, the first criteria of hash set is that no duplicate element will be added. So how it checks for that? It checks for that for two ways. Okay, so given a object, it calls for equals method and the hash code method. Okay, now the original by default nature of hash code internal, let's go towards that. So okay, first is called for hash code, sorry, equals method. It will check that if this equal to 0, return true. Okay, if it is not or it is null, it will first check out the get class. It will extract the class of that object and will check that whether the object is a playing card or not. So if the suit is equal to that, is not equal to that particular suit, it will check only for suit. It returns false. Otherwise, it will look, if it is same, then it will look out that whether the face are same or not. Okay, so first criteria here is, in this case, in equals method, it will check suit first of a card followed by face of that card. Now once it is done is, it will provide the hash code for it. Now how hash code has been calculated? It given by suits hash code. Okay, it will automatically calculate once you call it. Then it will provide certain formula which is already presented by them. It's not something I have written, and then it present the result. So earlier we just bypass this code and return our own code directly, right? So that when we are calling the object, it is always equal. So we are saying that it is fine. Then it passed the equals part, but then it will look out for the hashing part in this case. Okay, so then the once once we found that the hash codes are same for object, for an object with the one which is already present in hash set, it will consider as a duplicate. Okay, so this is how the process of, you with the help of hash code, they're trying to identify that whether the element is duplicate or not, and based on that only they will add that in hash set. Okay, so this is the concept of hash code, and hashing is present, which is as a prerequisite has been given, because now we will see more on the set part, that what are the operation are there. So in the background it will check for this kind of thing. That's why I have provided some overview about that, how elements are added in the set. Okay, uh, so if you have any questions regarding the hashing, please let me know. So let me check if there any code are available on, oh, sorry, comments are there or not. Okay, dev.ishan, see this is a called package. Okay, so given a structure, so I have a project called session. In that, idea out provided by directly by my IDE. Git ignore session 11 IML, all provided by IDE. Now whatever present within the source code is provided by me. Now it is a practice, general practice, that I should deal in terms of packages. Packages are nothing but a kind of folder structures where I want to keep my data. So dev.ishan, that is my dev is this for development, and EAS is initials of my name. So based on that, I just provided this. You can write anything. Okay, this the more if you put dot, it will create another folder into this, and within that folder you will play. You can have multiple what you say Java files in that. So because of packaging, it's easy for you to so if multiple files are there in multiple files are there in the one package, you can access that class, their variables or method directly. If it are in different packages, you have to explicitly specify that in which package your file exists, and from that you have to access the particular method, class and all. So for that, this concept of packaging is there. It's just for organizing your code in a different ways. Okay. Okay. Any other question regarding this hashing code part? Please let me know. Okay. So otherwise, then let's start with the set aspect into this, and let's start with the set as from the Java collection point of view and see that what can we do with respect to it. So few aspect of Java, few aspect of set. They are not implicitly ordered. So the way I added an element in the set might not preserve it. Followed by it doesn't contain any duplicates. Okay, a set may contain a null element, and sets are useful because they are very fast. Okay, now basic set methods have add, remove and clear to maintain the item in the set. Okay, it also use a contain method where it will it will iterate over all the element in set to get a element. Okay, so we will but there is no way to retrieve an item from the set, so that is also one thing that we will look into. Now another thing is hash set class that we have seen earlier. This is the best performing implementation of the set. Okay, it is very fast. It is very fast in the background, and it uses hashing mechanism. So I have given just glimpse of the hashing mechanism that it goes with the hash code and equal method. Okay, uh, so it has operation of add, remove, contain, size, which is it is inheriting from the set interface itself. Okay, and hash set is actually use hash map as its own implementation. We will look at hash map as well or as we go along. Okay, now so it's something called set operation. Okay, let me deal with the first set and then I will go to set operation as well. So for that I will go to main. Let me open up some files here, contact Java and contact data. Okay, okay, so what we will try to do is I just have some setup code which we'll use, and using which we will try to deal with the sets and maps and all that. Okay, now let's look into this. So for that, to deal with this, we have to create some certain kind of objects, right, for certain classes. So we have created a class called contact. Now this contact has two aspects into this. So three things. It has private string name. It might have the person might have an email, and the person has some phone numbers. Okay. Now this data I have explicitly specified in the contact data.java, where I'm directly specifying as a static final as a phone data, where I have some cartoon characters and there are some random phone numbers here. Okay. Similarly, I have some email uh, of cartoon characters as well. Okay. Now using get data, based on whether I want a phone data or email data, I will get the data possibly. So for that I have written some code here. Okay, this code will be I will share with you. So I'm not spending much time on the setup code. I just tell you what exactly was present in that. Okay, so contact data has so many of values, and now we will use these values to add in the set data. Okay, now right now it's currently is present as string. Now we will add that as a set. Now let's go back here. Now in the contact class we have name, email and phones. Okay, now emails and phone have been created as a hash set directly. Okay, that is one. Then we have a multiple uh, constructors. So all constructors are coming in a different form. The first is public contact, where I'm just assigning a name. Then public contact, where I'm asking for name and email. Or public contact, I'm asking for name and phone. And last, public contact, where I'm asking for all the three names: name, email, string. So using this function, function, I'm concatenating, I'm doing constructor chaining directly. So if I just pass the name, so I will just pass phone as email as null and phone as 0, like that. So it will keep on going towards it. Now if I have all these values, I will try to uh, put phone number in a certain format. So like the first three numbers are in a bracket, then followed by next 6 number, like that. Then to extract the, since the name is private, so using get name, we are extracting the name to string, just to, when we're calling the object of this contact class, we are just printing it in this format, followed, where name will be first, followed by emails, and followed by phone. And merged contact data is the function where we are merging all the emails and phone of a particular entity. Okay, um, then it has equals and hash code as well. So that is something I'm not getting into. It's written automatically by the IntelliJ. Then add email. So if you want to have so if I want to add an email for a existing one, or if the name doesn't have an email, for that I have this function. And if I have to replace an email, for that I am adding I have calling for another function. Okay, all this thing is this there. uh, Now let's go to the main function, and this is that was a helper code and setup code. So that's why I'm not written it, I'm just having it. So we have a contact class object where from the contact data I'm having, I will use this contact data to extract the contact class object, create a contact class object, and I will use hash set or any sets to deal with that. Okay, so first let me create some list. So list of contact type which has emails. I will use contact data dot get data. Okay, now once I do this, I will ask for specifically for email. So my list of email of contact type will contain uh, all these values that I'm asking for, email data. Okay, the name as well as email. Similarly, contact phones is contact data dot get data and phones. So I will get the name and the phone value. So just let me print the data directly. Okay, so I have to write print data, and I will ask for phone list, and print data email list. So I'm passing 2 arguments, so I have to create a print data thing as well. So let me create that. So I will just create a public static void print data string header. So if you have any question, you can unmute yourself and you can ask as well. Contact system.out.println system.out.println, and that's the header, and just now I will use for each function here. So for contacts dot for each system dot out. So for each element contact, I will just print it out. Okay, now if I just run this code, so we get the phone list and this thing. So we get the name, and we have one empty square bracket for that is for the email thing, and the remaining is the phone number. Similarly, the email list, we have email list, email with the particular name, and followed by the empty square bracket for the phone number. So as we go along, we want to try it out that wherever this there are few names which are common. So let's say Mickey Mouse is there in phone and email as well. We want to merge these numbers with this email as well. So how can we do that? That is what we are going to do in the next maybe remaining 1 hour session. Okay, using multiple sets and all. So we'll look into that using set and maps. Okay, so this is how it will look like. And now this is for list, right? Now let's our main thing is hash set, so let's create that. So we're creating a set of contact type, naming as email contacts, and creating a new hash set, and we're passing the list as emails. Similarly, set contact, phone contacts, new hash set, and then I'm passing phone directly in the constructor, and it will create the hash set already. And just let me print this data as well to see that how the set data will look like. So phone contact and phone contact and email contact. Okay, so now we have list. Now we create a hash set like this, right? Now, so as you might have seen next in the last 20-30 minutes that we can't have a duplicate elements and all those stuff, right? So but let's see whether we can have store such kind of things or not. Okay, now we got this output uh, as the thing of hash set. Okay, so what is happening here is, as you can see earlier, we might have more names. This output is from the string set list that we are having, even the email thing. But in phone contact we have less number of names and their particular phone list or email thing. So what is happening here is, it is looking at the name as a parameter for comparing that whether the element is present or not. So earlier Mickey Mouse has two phone numbers, it has only one as showing here. Mickey Mouse has two different email ID, but here it is showing one only, right? So it is taking only individual elements, it is removing the any other elements present, uh, any other duplicate elements present there. So hash set all automatically will remove that. Okay, so that is the first difference that we are talking about, and I'm stressing upon that because it doesn't contain duplicate element. Now if you want to know the index of a particular if you want to create an index, sorry, if you want to know the index of a particular element, so let's say you can do that, emails dot index of new contact. So I'm creating a new contact of name, let's say Robin Hood. Okay, now what I will do is contact Robin Hood emails dot get index. Okay, now what I'm trying to do here is, I created an object Okay, based on that I get its index when it's creating it out. I'm accessing this index out of it, and I'm trying to add two emails with respect to it. Okay, so let me just write it down. So dot add email function that is present in the and I'll just print it out, system dot out dot println. Okay, now if I just try to run this code, so if I try to add a new element, basically let's see how it will work it out. Because in the contact.java we have this add email stuff. Okay, so it is showing, oh, I think I have done wrong. I should have passed. Let me rerun this again. Okay, it is creating a new email based on the element present in contact.java, but it is also adding um, the email directly here in with respect to the set as well. Okay, it is doing automatically, and that is something I want to show you here. And yeah, it is happening here in the hash set itself. Okay, okay. Now if you want to add one more mail directly, so let's see that how the hash set will act towards it. So I'll just write the same word as earlier. So here I'm not changing the name, I'm changing the email address, and I'm adding it multiple times. Okay, so it has it also look out for that it already had an email of particular type. Okay, and it will not add it directly. Okay, so it has it also look for such kind of thing. It not only look at, it will first look at the uh, initial names, but after that we can also make them to look at the other emails and phone numbers to if you want to add new things or not. Okay, so that is what is about the hash set part. Now let's look at some of the operations with respect to it. What comes for the kind of operation that we can do on sets. Okay, now we have to see that what kind of things we can do, but one thing is, since set is also dependent on collection, so we can't have a separate new function for the set. So it will, we can have it, we have to manipulate the function called add all, retain all, remove all, contain all kind of functions that we have seen last time to perform the set operation. So right now I just go overview what kind of set operations we will see, and followed that we will do that in code after taking 5 minutes break. Okay, so if you have remember earlier that from your high schools and all, that to represent a set we use a something called as Venn diagram, right? So if we have set A and set B and its element, we can present in as a part of a circle. This is called Venn diagram. Now there is no overlapping aspect here, so there is no merging of two elements here. Okay, so these two sets have no elements in common. Okay, now, but if you have some elements in common, let's say in this case set A and set B has Goofy and Snoopy as one of the common elements, so we will say this is the overlap element, right? So based on that we can identify that which set has what kind of elements, and plus which one are common in both of them. So based on that, we have certain set of set operations with respect to it. The first is union operation that the set provides. So given, so this is taken directly from the email and phone numbers data. So let's say we have email data, So in this email and phone numbers, three elements, that is three members, Mickey Mouse, Minnie Mouse and Robin Hood, they are present in both email as well as in phone numbers. So when the union comes added, so we will add all the elements present in this set A and set B as well, including the overlapping ones, but overlapping ones will come only once. Okay, so that is for union. um, that is thing. And intersect, in intersection we will only try to identify the elements which are overlapping, and removing we will not add it, right, for them. So the intersection result will be like this: Mickey Mouse, Minnie Mouse and Robin Hood. So this is the intersection part, that is the elements which are common in both the sets. Okay, these set operation called symmetric operations, because if I do A intersect B or B intersect A, it will give me same result. Similarly, A union B and B union A, also the final set of element as the output I will get is the same set of name as well. However, there are some set operations which are given asymmetric difference. That means if I try to perform certain operation on that, the output will be different if I just change the set interchange the set values. So one set is one type of uh, operation is set differences. So let's say A minus B, if I have phone numbers and email. So here set difference what try to do is, if I have A minus B, it will try to find the elements which are present in A but not in B. So in this case, these two elements are present. But if I do B minus A, that is set elements which present in B but not in A, I will get a different results. So these are called as asymmetric differences, and these all operations we are going to do right now in our Java code as well. Okay. Now there's another thing called set symmetric differences. This is the one of the last operations here, which looks at the union of A minus intersection of B. So that means it will look at these values. I'm highlighting right now with the pen these values. It will try to give me as an output, and it will minus it with this overlapping one. So these called set symmetric differences. Okay. So these operation we will see right now in the code. Okay, so we will see that how we can perform this kind of set operation, and these are very quite common operation used in Java when you're dealing with a large number of records and all, right? And set operation are being used just because they are very fast in nature. You can compute the things because you're adding, removing and all this thing, it's very fast, so that's why you're using set operations. So we see that in the code. So before that, let me see if you have any questions as of now or not. Okay, yeah, I think someone has already answered, which data I'm using IntelliJ as well as of now. Okay, so it's already 1 hour, so let's take a 5 minutes break. Okay, coming that, we will now, what we'll do is we will try to we will perform set operations, and then we will try to see the maps as well within this 1 hour. Okay, so let's say it's already 7, so let's start our session at 7:05. Start the session at 7:05. Okay, so if you have any questions, please let me know. Otherwise, you can put down chat box, and once we come at 7:05, I will see them. Okay, welcome back. Now we'll see the set operations, how we can do the basic operation that we have seen just right now on the slides, the union intersections, set differences and symmetric differences, how we can do that in the Java. Okay, so this let's have something first clear. That is, we have set A and B, so we will dealing with that. So let's define what is set. So let's say set is A is email set and B as a phone set, the number of phone data that we are having. Awesome. Okay, now what we have to do is let me create a set of contact, and I'll just do union of A and B, union AB, and I'll just say new hash set. Now instead of you in that, if I have to add the things, since its hash set will contain no duplicate elements and all those stuff, I can directly use add all function to do that. So if I use add all function, I will add both email contacts, and email contacts are the contacts that we have created using hash set, and union A dot B dot add all phone contacts. And if we just print the data, so print data, and I will just pass this element here, so I can say A229, it's for union symbol that we are having, U kind of thing, union of emails A and with phone B, and then we will just pass it on this union AB. Okay, if I just run this code, yeah, I think should be fine, but it is giving red for 2229. Yeah, if I just run this code now, okay, I think I've given wrongly intersection 1, but I think I should cover it to A, not 9. Okay, but that's fine. It will not change the output that we are having here. So as you can see earlier, the email and phone contacts were different, but as we are making a union in this case, so we are getting some phone numbers. See, it's not, it's unordered. Okay, so that's why you're getting somewhere email first, somewhere phone number first, and all that. And also you can see that Mickey Mouse was present in both phones and email, but it's present, it is random, it is giving me only email aspect here because we are passing A first. Okay, so we are getting some email as well as the phone number values with their respective name. Similarly, let me do for intersection as well as set differences and all that. So for that I will just copy this line of code. Let me write those things. So for intersect, I can use intersect AB, and for intersecting, what I can do is I can use retain all function. So retain all email contacts. Now what retain all function will do is it will as we are adding, it will keep all the elements. Okay, and the ones which are coming as a duplicates, it will keep only those elements in that. So when we are adding email and phone contacts directly, it will look for the duplicate elements present in email and phone, it will take that only, and remaining it will remove. So for intersect this thing, it's 229, and this I will let me write it as um, intersection of um, phone, and I have to change this as well, intersect AB, intersect AB, and emails, and finally this. AB. Okay, this is one thing. We also see, as we are seeing, that it is symmetric operation. So let's see that if we do BA, how it will work. So if I pass first different set first in different order, will it going to change any aspect here or not? Okay, another thing I can do, instead of retain all directly here, I can also pass it as email contacts directly as a hasset during constructor, and I will just keep it like this. So in this case I can add phone contacts and remove the retain part, and I can write it as B intersection A phones with this is A, this is B, and here I will add at BA, intersect BA. So this is for checking that if we have providing sets in a different order, will it changes our result or not in sets. So that is one thing we are doing. Also what we are trying to do here is set difference as well. So A minus B, and I will just write it email contact, and to use email set difference operation, we will use remove all function with contact. So I'll just write it as A minus B. So just say email A with minus phone B, and I'll just write it as A minus B. Similarly B minus A also I will do it, and then we will see all the output together. B minus A, and I will, instead of email contact first, I will add phone contact. So again, the sets that you're trying to provide here, the order, it matters a lot in this case. Okay, yeah, I think email A, B, and A. So now, okay, so we have seen in union. Now we are doing for intersection with keeping different set orders as well as set differences. So let's run this code. Okay, let's look at it one by one. Okay, this is the union that we have seen earlier. That is, we are combining both the sets values, and wherever that's common elements are there, we are just removing them. We are keeping only one order type of it. Okay, in intersection, when we are doing A intersection B, both the answers are same. That is Robin Hood, Mickey Mouse, and Minnie Mouse in this case. So that means this shows the set symmetric aspect into this. Okay, so both answers are same. Only difference here is, even though names are same, the values here are different. So the here in the A intersection B, the values are coming from the email side, because we are uh, doing keeping email first rather than phone. But when we are doing B intersection A, we are asking for phones as our output. So that's why it is values are in name by names it is same, but values might it means different. Now this is called for set difference, that is A minus B. So in that, whatever the element which are present in A but not in B, that is what we are trying to get here. And here B minus A, whatever present phone numbers are there but not in email, that is trying to get it here. Okay, so here uh, the values, as you can see, that might be different here in this case, but that's how it is because the values are always different. It's not, it's called as anti-symmetric operations. So that's what we will get here. uh, okay, I think that's for symmetric differences. Then what we can do is, okay, and symmetric and anti-symmetric differences, there's another one, one more last operation for set. So let's create one. So set of contact type symmetric diff new has set, and we are asking for passing one a minus b set as out as a parameter for a has set, and we are finding symmetric differences, that is add all b minus a, and then we'll just printing the data. Symmetric difference phones and emails. Yeah, that's one thing. And last one that we try to do is for union and set operation. So set contact, nothing. Yeah, just let me write it down directly. Symmetric diff 2 new has set union AB diff symmetric diff 2 dot add remove all intersect AB and print data symmetric difference phone and emails. Okay, and then I'll just print out this value. So if I just run this code, so what we are doing is we are adding a minus b and b minus a, that this value that for symmetric difference, as well as union a. From union a we're removing intersect a and b. So how, what the output will be, let's look at those values as well. uh, but why for last data it is not printing? Okay, okay, so first data it is for, it is printing like uh, how it's supposed to be. So it looks at the values that we are having. So uh, so a minus b and b minus a, if you look at those values, these values and these values, from here it is combining all those values, and that's how we are getting this values with no what you say, with no overlapping of the data or no difference of data. For the last it is not showing correctly, so let me see. Union AB intersect AB set contacts print data. Ideally it should work. Okay, I will check that where it's wrong, but ideally it should work here in this case. Okay, that's fine. So this is basically few of the set operations that we have seen here: symmetric operation, asymmetric operation, symmetric differences, and all those stuff. Now let's look at a much more. Let's go deep in terms of set and look at what we can see with what the things that are offered by Java. So till now any set that we are passing, so it is not keep in a particular order. Okay, as we push any values into the set, it will store in any order. Okay, but we need some kind of order set from time to time, we need that the way we have added that value in that set, it should be preserved in that order, or it should maintain a certain kind of order, the natural order of elements. So link hash set is one which maintains the insertion of that element. So the way I've added that into the element that we have seen as of now in list, arrays and all, the way we added the values, it will append at the back of the at the back, right? Similar, but in normal sets it we can't do it in hash set, but in link hash set we can do that. Similarly, tree set is a kind of binary tree at the back end, but it so based on that, tree set, when in whatever way you try to pass an element, it will always keep that in a sorted order. Okay, so it will look at the natural order of an element, that is by string values or numbers value or numbers based on that, or we can also create our own comparator to sort the particular set as well. So we look at both this linked hash set and the tree hash set right now. So link hash set extend the hash set class, that the one that we have seen right till now, hash set thing. It maintains the relationship between elements with the help of doubly linked list, because it's a linked list kind of thing, and the iteration order is the same as the insertion order. Okay, so the order has been there, so that means we can predict that at which element the order the element would be stored. Okay, all the methods in link hash set are same as those of hash set, but the way that data has been stored is different. Okay, and it also have add, constraint and remove operations. Now tree set is basically uses data structure of a binary search tree at the backend, or B tree for short. Okay, it will help us to search the element in a much faster way. Okay, so let's look at create a new main function, a main class, and there we try to deal with the same contact data, that one we are having here, and see that how it will work it out for the tree set. So for that I will create a new Java class. So let me name it as tree set main. I'll have public static void main. Okay, now few things I will take it from here. So I will first create a list of phones and email from the contact data.java. So I will directly get it from using contact data to get data. I will get the list of all the elements which are which has name as well as email, and the from phone name as well as phone number. Okay, now what I will try to do here is let's create so this also a tree set not only derived from the sets, as well as there's something called as navigable set as well. Okay, so we'll look into that part. So how do we sort a tree, given this email and phone number, how can we sort it? That's the thing, right? So we look at different ways of sorting this. So let's look at it one by one. One is that we create a comparator. So let's look at we create a comparator object of contact type. I will name it as my sort, and I'm defining that how my comparison should be. So I'm using the function called comparator, the comparator or comparing. I will say that from the contact, any contact object, I should look at the name. So I will use name as my comparison parameter. Okay, then using navigable set, it's an interface. I will create a type of contact here, and it is name it as sorted, and new tree set of my sort. So I'm passing this comparator that I should sort my tree, whatever the contents present, based on the name. That's what we're trying to do. And then sorted dot add all and phones. Okay, now now earlier we are doing print data. So what best way, one of the best way to print it, or one smallest way to print out any set and all that, is using for each function that we have seen earlier as well. So I just do sorted, the object that we are having, tree set data, and I will just write it down for each as a lambda expression, and system.out.println. Now if I run this code, So we have compared our elements with respect to the names, that is using the get name. The comparator using this, we are getting the name of Charlie Brown, Lucy Van Pelt and all that, and we are sorting it based on the name types, that is C, L, M, M, R, kind of like that, alphabetical order. So that's how we're trying to print it here. So that is one way of doing it. If I don't, let's say if I don't want to make it like that, I don't want to have a comparator, then what should I do in this case? So what for that I will do navigable set of string type. I'll just take just names and I'll create a new tree set. Now for phones, which is basically a list, for each element in the list, I'm creating a lambda expression here. In the tree set element, I just need to add c dot name. So I'm just adding names in the tree set, and if I just print it out, system.out.println, sorry, just names. If I just run this code, so I just created a tree set. I haven't specified how should I sort it, okay, but I am taking only names in that, okay, nothing else. So if you see this, it will automatically also, without explicitly specifying for a comparator, it will automatically um, sort them based on their names. So like CLL, the same way that we have seen earlier, the same way we can do it here without explicitly specifying the comparator. So that is one way of doing this. Now, but if you want to still want to say that that I want to sort my thing with a specifically um, with my specific comparator, I don't want to create this like that, so we can invoke that object as well. So I will just say that navigable set contact full set new tree set and specify how it should be sorted. Then I said full set dot add all elements from the email list, and I will just use full set dot for each and just print it out. If I just run this code, this sorted object that we have created is from here. Now what it's trying to do here is, in the full set, it's taken the sorted value. The sorted object also has phones value already present. Now we are just adding emails to that. But now this, since sorted value, sorted object uh, has has been comparison with respect to the name. So what we are trying to do is, when we are adding the email IDs also, uh, we are looking at whether the name present or not. If the name is present, we are not adding any email value. That's why you can see here only two values has email, rest of them has phone numbers, because rest of the elements which is present in email are also present in phone. But since phone are already present, we can't add it because of the duplicate elements. Okay, so these are few other ways of how we can invoke a tree set. Now let's say if you want to sort the list by combining two lists based on alphabetical order. So if you want to combine two lists, this is one way that we have seen. Another way is, uh, let me create a list first, list contact and full list new array list, and I will just pass phone as a parameter, then full list dot add all email, and I will pass the full list dot sorted dot comparator, that is with the help of name. And if I just do system dot out dot println just as a differentiator, I'll just print out the full list, which is basically a array list in this case. Okay, now once we do this, now we can see it's not a tree set, it's just a normal list, and we can see all the type of email with the multiple elements and all duplicate elements here with respect to name as well. So let's run it. Yeah, so as you can see, it is all, everything has been sorted based, it's a dimple list, not a tree set in this case, but they have been sorted based on their names. But what you can see here is after that Mickey Mouse has so many numbers as well as so many emails as well, but that has been preserved in this case. And while we are, even though we are adding it, when we are using this function called full list dot sorted dot comparator, when we're doing sort function, we have to tell that how it should be sorted as well. So for that we are using the tree-set object of sorted, name as sorted. In that we're using the comparator function. This comparator function we have just created above in this place, that is using get name. So using this thing we can get access, we can specify that how we should be sorted, and based on full list have been sorted. Okay, now let's do this few more stuff in this case. This few functions call as min, max, first, last, poll first, poll last. So these few functions are available in the set aspect as well, from where we can extract the element from the set. uh, so how can we do that? So let's see that aspect as well. uh, so let me create contact min collection dot min. I'll pass this tree set a full set as well as full set dot comparator, which is by default function is also available for any tree set function, sorry, tree set object. Okay, so what happening here is collection is a collection class which is a helper class, and it has been extended to all the kind of sets, maps, linked list, array list, and all those stuff, so we can directly use it. So using this we are passing the tree set, that is name as full set in there, and we have sorted it, and from the sorting we are trying to find using min function the first element that we can get it from there. Similarly, the based on the sorted value, similarly max function will extract collection.max, will also take full set comparator, but it will extract the top element from it. So that is one. uh, Similarly, if we don't want to write it like this, that is because collection is there, we can use directly first and last function as well. First full set dot first function and last full set dot last. So it is coming from the set functionalities. We will see that what the output here is, and just let's print it out. So system dot out dot println, let me have some separator here, and okay, now let me print it out, this first and last, printf min equal to %s as well as first equal to %s %n, and then we are passing min dot get name as well as first dot get name. Similarly, for max and last, let's look at it. So max and last, so min max dot get name and here last dot get name. If I just run this code, so it will give us the same answer because this first and last function and the min and max function from collection framework, so a collection class is same, so it is giving us same thing. But now there is something different come when we use the poll first and poll last. So let's look at that part as well. So for that I will create a copy set. So navigable set contact copy set new tree set, and I'm copying the full set here. So then from here copied set println first element is equal to, it will give us the same values as we have seen earlier, but there is some slight change into how the final output will look like. Similarly, last element copies set dot poll last, and then we will print out each and every element of the copied set as well. Copied set dot for each system dot out println, and then a small separator. If I just run this code, okay, so here the first element was Charlie Brown, max was Robin Hood, same for first and last. Similarly, here first element Charlie Brown with the phone number, Robin Hood with phone number, it's present, everything is fine. But the copy set that we have taken here none of the names of Charlie Brown, Robin Hood present. So what does it mean here is that poll first and poll last function removes, not only extract the element but also removes the element from the set. So that's what it is, make it different from the first and last function in this case. Okay, so that is something you have to be careful while using these functions when you try to write a code for tree set or any kind of sets function. Now once that is done, there are few more functionalities present by set, that is sealing, that seal function, floor function that we are having, right? So that these functions and floor and lower. Okay, so these values are there, that is something present, these four functions are present in the tree set or any hash set functionalities as well. So let me write some code to how to use these functions. So I will create some more contact objects here. So let's say new contact Daffy Duck, contact Daisy, new contact Daisy Duck, and let me create more contact Snoopy, and contact one more, last one, this is Archie. So I've defined, they created the object and defined their names as well. Now let's add it as a list in this case. So for contact C and list of, and I will add these objects from the contact. Daffy, Daisy, Snoopy, and Archie. So I will traverse each of these elements one by one. Okay, now once we have this, now I will just print out the ceiling and higher function in this case. So system dot out dot printf ceiling percent s equal to percent s and percent n, and just like c dot get name followed by full set dot ceiling. Okay, so it once it gets the name, it will try to find the element which is greater than or equal to the ceiling. Okay, and let me dot for higher as well. And I have to write higher in this case. Higher C name get name, and in this case higher C. Okay, similarly for floor also I can do this, floor and lower. So let me copy and just paste this, and so I will say floor C name full set dot floor, and lower full set dot lower, and a separator. Okay, so let's see the output and then discuss that how the ceiling, higher, floor or lower function will look like. Okay, so it is giving us lots of value, but look at it one by one. Okay, so ceiling is giving Daffy Duck, higher has given us some different for Daffy Duck, floor has given us a Daffy Duck, and Charlie Brown has given us Daffy Duck is Charlie Brown. Okay, now how to interpret this outputs here? So let's look at here in the slides. Okay, so in the tree set that we have created as a name of full set, this is how the values might be stored in that particular thing based on the names, right? Since it's a binary search tree, Mean Marion is a top, followed by Linus Van Pelt, Charlie Brown, Daffy Duck, Minnie Duck, and all those stuff. Okay, now the left node, this part is anything which is less than the main Marion, and the right part is anything greater than the main Marion in this case. Okay, so these values are less than main Marion, and this Minnie Mouse is greater than the main Marion, like that. Okay, so I'm not going to develop into the how binary trees works, but I think you might know much better here. Now once we have this, once we are going to locate all these values, now when we are saying the floor and ceiling values, so let's say Charlie Brown here, it will look at what its higher value and what is its lower value. So it will look at the nodes which are higher and lower, and based on that it will try to tell that higher and ceiling high value and ceiling value in this case, right? So like higher value of Daffy Duck is maybe Linus Van Pelt, and Daffy Duck is greater than equal to of Daffy Duck. So to show that how it will work, yeah, this is much better. So in a particular set, if you're using floor thing, so it will be less than or equal to, so it will say this as a match element. For lower, it is like less than only. So let's say floor value of Daffy Duck is less than equal to, that is Daffy Duck and Daffy Duck, and anything lower is less than. So anything below Daffy Duck is Charlie Brown. So how do we know it's less than like that? Because we have, when we are trying to sort it down, we are sorting based on their names. So based on that only we are extracting these values. Similarly, ceilings are greater than equal to, and higher is actually greater, right? And if null, if none has found, if it is top element, it will not found anything. So for Daffy Duck, higher is Linus Van Pelt, and ceiling is greater than equal to, it's same as Daffy Duck. But you can see that for some values the ceiling is higher is null, because that means it was a topmost element that it has in the tree set. So that's the reason that it is getting like this kind of answer. Okay, now this is for uh, ceiling, higher, floor and lower function. Okay, now there's some what we'll do is there's something called descending set here. Descending is like kind of descending sort that we are trying to do. So that, and we will look at some more, I think more subset functions. So we will look at descending set function and some subset functions uh, in the form of tail set, head set and the subset. So we will cover these few functions and then we'll wrap up the session for today in this aspect. So these are 4 functions that we are talking about. Just a minute. Yeah. Okay, so descending set is basically, in this aspect we are trying to print it out in a different in the order of, like if you have alphabetical order, it will change that order in this case. So to do that, I will just say navigable set contact descending set full set dot descending set. Now full set, you remember it's a tree set that we have created earlier, and now we're just printing it out, descending set dot for each and system dot out println. Okay, and then a small separator. If I just run this code, okay, so it is starting from R. Earlier it was starting from C, now it is starting from R, right? Now one more aspect that I want to show here in this case is, now we have seen earlier that pole last and pole first element, right? It removes the element from the set. Now for that we are creating a different set, descending set, where we are trying to do. Now the question is, if I remove any element from here, will it reflect to the full set or not? Okay, so that is something we're trying to see here. So for that, what I will do is, let's say contact dot last contact, and I will just say descending set dot pole last. Okay, so I will remove that last element. I will extract the last element and automatically will remove. So let's say I'll just print it out. Removed last contact. Okay, now I will just print it out the descending set, because from there I will do the pour last for each system dot out under colon underscore println, a small separator, and I will also look at the full set as well. So full set for each system dot out and colon println. Now if I just run this code, okay, now the Charlie Brown was removed because of poor last thing, and this is the output of a descending set that we have found now. But unfortunately in the full set also this value has been removed, even though the values in order also different, but still it was removed. The reason is the navigable set, that descending set that we are finding, is basically a reference variable in this case. Okay, so any changes I'm making the descending set is also reflecting back in full set as well. So that is one thing that you have to keep in mind, that if you're trying to create such kind of scenarios using descending set or any other thing, you have to keep checking that if you are making some changes in the poll last, or you are using some function called poll last and poll first which can remove an element, you also check that whether it is reflecting your original list tree set or not. Okay, so that is one thing. And finally, let's look at the subsets from the original sets. So how we can do that? To do this, let me create a few objects. So let's say contact median equal to new contact made median. Okay, now var, if I do head set, and I will use a function called full set dot head set. Okay, and just provide the median as this, and I will just print out the head set in this case for each system dot out println. Okay, and then a separator. So we'll talk about how the headset is. Let me do one more thing. In this case, I will create a tail set as well. Tail set, and okay. So what we are doing is we are calling a function called headset for a tree set called full set, and we are passing the object called Marion in this case, and we are calling for the tail set for the Marion as well. So let me run this code. So see that how it creates a sublist. So it basically creates a sublist or subset. In this case, subset is the appropriate word here. Using head set and tail set. Okay, so these are the two outputs that we have printed out. So what is happening here is headset in the headset, anything which is above the made variant is printed here. So these three values, it is printed from the headset, so it is taking that subset, while tail set automatically include that one from where it is has to take a subset and the remaining items as well from the set. So these are the headset and tail set value, but here there is a overloaded function is also available. So what you can do here is you can specify that whether this is act as a division between the sets, right? So here in the head set it's not including the one which is as a division. So what shall we do here? This overloaded function is present. We can specify that this object which act as a division in the subset, whether to include that or not. So if I just add as true here, and for tail set also we have a overloaded function as a boolean value. So if I just act as a false, that I don't want to include that uh, divider object as in my set. So if I just run this code, okay, so it will add that the headset, this is the output coming from the headset, that where we are including the parameter called inclusive as a true, as a boolean value. And in the tail set where earlier it was made Marian was present, now it was not present because we have put that inclusive value as false. Okay, so these are some overloaded functions present in the tail set and the headset as well. Finally, the last kind of subset creation that we can do is subset functionality. So for that, let me create one final object called Linus, and let's say the contact, new contact, Linus Van Pelt, and let's say var subset, yeah, let's keep a var subset full set dot subset, and I'll just pass the division values. Okay, and I'll just do subset for each system dot out println, sorry, and I think the last operator is not needed in this case. If I just run this code, so I just call here the subset function in this case, and we provided two values instead of one, two objects, and let's see how the output will be. Okay, so it is providing me only two values in this case, that is Linus Van Pelt and Lucy Van Pelt. That's the only subset that having. That means it is giving me only these two values out of it. Anything which is starting from, so it is so this is the original list that we are having, I am highlighting right now. So when we are providing Linus and Marian in the code, that means it will start from Linus and it should end till Marian. But in the subset we have to by default it is saying that the first element that we are object that we are passing will be present as well as the remaining one. The last object which we have to find, it will be excluded, right? So that's where made Marian was not there. But if you want, if you know that before and starting index and the ending index of that of a particular element or elements from which you want to create subset, at that point of time you can use the function called subset directly, and that's how you can create a subset uh, present from the full set tree, and that's the last values that you are getting here. Okay, and it also has overloaded function, that is we can specify that whether to include both or not. So let's say let me copy this function again, and I can have overloaded function where I have to tell false and true. Okay, so whether to add Linus in the subset or not, whether to add Marian subset or not, if we can specify here, and if we run this, that will also give us we can create our own subset out of a given tree set. Okay, so this was the original uh, tree set that we're having. From that we are creating subset Lucy Van and made Marian. That means it's taking only these two values from subset and we providing the starting and ending indexes Linus and Mead-Marian. Okay, so that's how we can deal with tree set in multiple phase. So we have seen lot of functions today in this aspect. From tree set we have seen min, max, first, last, pole first and pole last. These are the first one. Then ceiling, higher, floor and lower in this case. Then something called descending set, and three function called to create a subset: tail set, head set and subsets. Okay, as well as we have also look at the hash set as well in this case, where we have looked at some of the set operations of union, intersection, differences, symmetric differences as well. So we have covered quite a lot from the Java collection, but one more thing is still remaining, that is map. That thing, I think it's all time is over, so maybe next session, in the last session, I will cover the maps as well. I will complete the maps and we'll complete the whole Java collection part in this aspect. So yeah, so that's the end from my side as of now. If you have any questions, please let me know. Otherwise, the session is end. Okay, copy of this code. Yes, I am giving this. So let me stop presenting now. Let me give the code this code as well. Give me a minute. Let me share this links. How should I write? Just a minute. I think it's loading right now in my system. Also, will the previous year paper will be discussed in any session? That previous year papers, there's no access for us to look at the previous year paper as well, so we can't do that as of now. Copy, I'm just still loading right now. I'm still waiting to load. Yeah, I think I can do that now. Okay, yeah, I just shared that code, so please take that right away. Click on that link, you will get that this set of codes that we have covered today. Only the map part I will cover in the next session. Okay, so any other question as of now with respect to what we have covered today with respect to Java collection or any other thing, you can just let me know. Okay, in that case, let's end the session today. So thank you for joining till end. um, I really appreciate it. And since as the tests are also coming near, so keep on practicing your Java thing, um, because you have to eventually have to write Java course, and that's why you're learning this programming language as well, right? So all the best, and I'm ending the session for everyone. Thank you everyone.